Why is no company doing this yet? And then I've sort of realized you need a very specific skill set to be able to do it.
Hey, Jesse, do you remember the other day we saw Will on Tesla Jigsaw and he was talking to Chris at Qube? It's those big batteries.
Oh, right. And you can charge an EV from them.
Yeah. Well, I've got Chris here on the line, so let's talk to him about it.
All right.
Hey, Chris.
Hey, how you doing?
So, yeah, we saw Will charging at one of your charge cubes. Can you tell us a little bit about what that is?
So Qube is basically where batteries go to retire, is sort of what I've started calling it. The retirement home for batteries, be it Tesla, BYD, VW, whatever they are, it doesn't really matter. It's just mainly it's all focused on second life. So we're not doing brand new batteries in Qube. It's all about cycling of batteries. When they hit that 80% degradation and people don't think they're good enough for their car, or when someone accident damages their vehicle and you go, right, what do we then do with the battery? People find it really easy to resell all the parts, but the batteries tend to be that one thing that people don't want to touch or people are scared of, or actually battery recycling hasn't really become a commonplace yet for a lot of countries. So Qube takes those batteries, puts them into containerized form factor. So we can get roughly 450 kilowatt hours in a 10-foot container. But that also includes all the power electronics. So we've got the DC to DCs, AC DCs. So you can bring like solar in, wind in. We could put DC outputs then to rapid chargers or AC chargers.
But I heard on the internet that once batteries in an EV are done, we throw them in landfills or we burn them and it's horrible for the planet.
A bit like nappies, isn't it? They never die, they never degrade. They just sit there forever. I mean, what we found from a lot of the reports we're seeing, like you guys have, is, Tesla batteries are good in a vehicle for over 200,000 miles before they even hit anywhere near 80%, depending on how they've been charged. And then after that, looking at the degradation curve, we're thinking we've probably got 20 years, 15, 20 years. Some may even last longer. I think it depends on the manufacturer, because we obviously have seen some issues with batteries in the past with some of the OEMs. When they first started out, they weren't as great. But the newer batteries these days, we're really seeing them last for a very, very long time.
And so essentially what you're making is a gigantic, like one of those camping batteries that you can buy, except just scaled up to 11. And instead of buying obviously new cells, you're putting those EV battery packs in there. So what is it like to do that? Do you take an EV, as a whole and then get in there with a screwdriver and pull out individual cells and then stitch them all back together? How does that work?
So what we're trying to do is we're trying to keep it as a complete battery pack as it comes out of the EV.
Interesting.
So if you take a Model 3, for example, the battery pack has all the liquid cooling system in, obviously all the cells, full battery management system. You've then got your charger, DC to DC, all the safety systems like the pyro fuse, the contactors, everything is in that battery. And it's also fire tested, vibration tested, submersion tested, as we've seen people driving Teslas through lakes and all sorts of stuff. So we know those batteries are so well made and designed, and they've had crazy amounts of money spent on the development. We try and keep it in its exact form factor and then put it into the Qube, bolted in the same way as it was in the vehicle as well. Mainly because you don't want to just bolt the outside and not the middle, and the middle sags over time. So it's trying to make sure you support it in the same manner it was in the car. But it just means you get a crazy high quality battery pack, normally way higher quality than you would have got if you went and bought an energy storage battery pack, because most of them are B grade cells or C grade cells that aren't, say, good enough to go into automotive. So the quality level you have to hit for energy storage for battery cells is not normally anywhere near as high as the quality level we see in automotive, because they're just not doing the crazy high discharge rates we would see when someone, apps floors it and does sub 3 seconds, 0 to 60. You never get those massive power draws like you'd normally get in a vehicle into energy storage.
That's interesting. Now, do you try and keep the same batteries, so like Tesla batteries, all in one cube, so to speak, or can you mix and match?
So we try to stick with the same just because we know then from a serviceability point of view, if there ever was an issue, we're swapping out that type of battery. But theoretically, we run the batteries in pairs. So say we have 450 kilowatt hours, that would be 6 battery packs, but they're each in pairs. So they're paired together in series. So we don't link any batteries in parallel. It's normally a pair of batteries. So we'll take a 400 volt Tesla battery and we'll pair it with another one in series to get to 800 volts. That will then go into the high power, the power electronics like the DCs. But it means we're never linking them in parallel. So if you've got a battery that's on 80% degradation and one on 90%, you're only as good as your weakest battery. So you'll end up degrading the good battery to the older battery over time. So by keeping them separate means they degrade at their own rates. And then we'll basically feed that into like a common DC or an AC bus. So they are linked together, but after the power electronics, not beforehand.
Interesting. So, okay, so you have two batteries in series, and then they both go to the bus, and then you have another two in series, and they go to the bus, and another two in series, and they go to the bus, and then you have your battery.
Yeah. But they go through the DC to DC before they go to the bus, if that makes sense.
Oh, okay. And so what does the DC get them to after that? I mean, you don't have to tell me, but...
No, it's fine. So DC, depending on what we're doing. So a lot of time for CCS rapid charging, for instance, we'll have 3 sets of batteries all linking through 40 kilowatt DC to DC units. And then those units can do 0 to 1,000 volt output. So when you plug your car in, and it goes, right, what voltage is your car at? I'm at 300 volts. My target is 400 volts. Right, okay, well, we're going to bring the DC to DCs on together, get to 300 volts, and then we're going to slowly raise them to 400 to charge your car. Or you might pull up with, say, a Taycan or a Cybertruck and go, I'm an 800 volt system. So it will go, right, you're an 800 volt system. So that's those DCs are there to do that. They'll come in, but they'll do a buck or a boost. So they'll step up or step down depending on what voltage you want to output through the CCS charge port.
That's crazy. So, I mean, these DC to DC converters are beefy. They're not the ones that are... Not the one in my Leaf that forgets to charge my 12 volt battery all the time, huh?
No, these are like rack mount units. So you like server racks, where you just rack them in. They're basically that. They're a fairly big size unit, probably about 30 kilos each. Wow. They do air cooled, liquid cooled ones, but with the ones we're using a 40 kilowatt, you can get ones that do 80, 100 kilowatt now. So they're getting more and more powerful. But they're pretty stable. They've been obviously used in DC rapid chargers for years. We're just finding ones that do DC direct to DC now, instead of most of the ones you'll find in a DC rapid charger that you charge your car on is bringing AC in, then converting it over to DC. We're trying to stay DC to DC because it's a bit more efficient.
Nice.
Now, where do you get these batteries? Are these wrecked Teslas? Are these just Teslas that people got tired of driving? Like, where do you find them?
Yeah, there's loads available at the moment. So it's a mixture. So there's a lot of accident damage Teslas. As we know, especially in the Tesla world, it's hard to become an approved repairer for a Tesla. You've got to follow certain standards. Therefore, there's a lot of Teslas that get written off, which aren't normally that bad, but they get written off because the lead time to repair is long and all this sort of stuff. So there's a lot of written off Teslas. Like Copart in the UK, any one time, I reckon there's probably at least 12 Teslas on there every day. Like they're constantly on there. So there's a good supply of sort of accident damage. So it means we're recycling those batteries, and the parts can then be recycled and sold as well that come off them. Or it's high mileage. So we've got a lot of companies we're working with that do, say, rentals or leasing. And like if you lease a car for 3 years and it comes back in, maybe you lease it for another 3 years, but then once that car hits 150, 200,000 miles, what do you do with it? Like, can you really release it again? With a lot of these rental companies, they're not going to release a car when it hits 200,000 miles. And do they really want to sell them is the other question. They've been used and abused as lease vehicles. They're probably not best condition. Do they want to go and flood the market with hundreds and hundreds of high mileage Teslas, or would they be better off to recycle them? So they're not sort of causing themselves competition, shall we say, on the market. And the same stands for other things like vans, electric vans. Like we all see, you guys probably see loads of the Rivian electric vans. We see loads of other vehicles, electric vans like Amazon and all those companies. But those vans get absolutely battered by the delivery drivers over a couple of years. And it's like there is no resale value on these things. They're they've got massive dents in them, doors missing, damage. Like they're just wrecked. But normally the batteries are fine because they've been maintained by a battery management system, by the drive system. So potentially we work with these, worldwide rental companies. And it's like, well, you can give a set value to the battery pack at the end of life, which means they know they've got set value on the van and they're not just scrapping it. So that's giving us a continuous feed in of batteries long term.
The only thing I can kind of compare this to, I guess, would be like a mega pack or something. So how do these compare in terms of price? If I was Tesla and I wanted to have some mega packs at my charging station to kind of level things out, if I wanted to buy a charge cube instead, is this comparable in price?
So it should be considerably cheaper. And the main thing is we're competitive with Chinese pricing, if not cheaper. So that's the main thing, is we can manufacture them in country. And that's what makes it really good. So if we're manufacturing in the US, yes, the power electronics and some of that may come in from overseas, but we're sourcing the batteries within America, or we're sourcing the batteries within the UK or within Europe. So we're not bringing these batteries in potentially from China. We're just using the batteries that are already in the country rather than being re-imported again. And that seems to be a key thing, is from that point of view. Pricing point wise, so a 450 kilowatt hour charge cube as such, the base version starts at £120,000. I don't know what the conversion rate is into dollars. And And that will give you the base one with, the base power electronics to do type 2 charging. But then we can put different power modules in there to do DC rapid charging as well. So we think we can do up to 240 kilowatt DC rapid charging per connector on the Charge Qube, mainly because those batteries were designed for crazy high discharge rates. So even with 450 kilowatt hours in there, we can potentially do 2 guns at once, outputting 240 kilowatts at the same time without the batteries really breaking much sweat.
So talk to me about the use case of a Charge Qube, because I think that many EV drivers have probably experienced a high-speed charger, and usually, there's the thing that you that has the plug, and you plug it into your car, and then nearby somewhere is some gray or green transformer box that's quietly humming in the background, charging up your car. What is the use case here? Because I haven't seen, or at least I haven't thought I've seen a lot of battery powered charging stations. And then it always brings up the question, well, what is powering the battery station?
Most locations say have enough power over a 24-hour period to charge enough vehicles, but they don't have it at the point in time needed to pull, say, 200 kilowatts peak at that moment in time. So the plan with the Charge Qube is you plug it into the supply you have available, and you just continually trickle charge it. So you just slowly keep it topped up. Then when someone comes in and goes, I want 200 kilowatts right now for 30 minutes, the battery does that buffer, and then it just carries on topping up off of the supply that's there. And that's the key thing, I think, is that what we're seeing with the grid globally is that there is enough power on the grid for everyone to go to EV. The power isn't the issue, it's the power is in the wrong place at the wrong time. It's not there's not enough power. I think that seems to be that key thing. So the batteries are doing that buffer, which is why we're seeing so many mega packs being put out all over the world, is that they're getting dropped everywhere to do that buffering of power in key locations where needed. The other thing we can do is say you actually do have enough power at your site, but power is way cheaper between 12 and 6 a.m. in the morning. Well, why not charge the batteries up at that point in time and then use it in the day and use that power that you bought for a quarter of the price to then sell back to customers at a higher price throughout the daytime. So you can also, there's a way of making additional money there as well. Or you have solar in the day, but you need to charge at night. Well, you charge Qube up for that in the daytime with the solar, and then you use it at night when you need it. So there's loads of use cases for this, which what makes it quite an exciting product is it's very versatile. We can basically take this fundamental 10-foot cube, but build it out with different power electronics depending on the customer's needs.
Now, you mentioned beyond the UK, you just mentioned US and Europe as well. Are you going to be in those markets, or are you in them now?
Definitely. So US is the key market we're going to be moving into, I reckon, within the next 12 months or something. We're just raising money at the moment to grow. Plan is to build a fleet of Charge Qubes and get them out there. But what we really want to do is be able to, we're not expecting to say sell these. We want to offer people some really good leasing options so they don't have to go and find a huge amount of capex to buy these units. It's like, actually, you could lease it over a 3, a 5, or a 10-year period for your location, and that comes with a service agreement. So and what you'll find with a lot of the batteries that are being imported into these countries is, yes, you can buy this battery from, say, China. I can bring China up a lot, but from China, they seem to be the one that makes those batteries. You get it in, but it's like, well, what's the service of that? Who keeps parts to repair it? Who's going to repair it? Is there a service team that back it up in the UK or the US? In a lot of situations, there's not. You're just hoping that they're going to stay reliable long term. So the benefit with Charge Qube is manufactured in country. We have service technicians in that country that know how to look after it. So we'll offer basically a long-term service agreement to just maintain and look after it throughout that lease and beyond. So it's always online. Or if something does go happen, we can go and fix it. I think that's the way of making people feel comfortable that we use second life batteries as well, is they know they've got that as a backup, that they've got that support. Whereas if not, I think second life can scare people. Even though the quality level is really good and these batteries are going to last a long time, some people still trigger in the head and go, second hand, what if it breaks? What's the warranty on it? Well, let's give a proper long-term support with it.
And so who's the customer here? Can I be a restaurant owner, let's say in the US, and be a customer of yours? Or do I have to be a geek who knows everything about how charging works and, at that kind of high level?
Theoretically, no. So the plan is that we will be able to basically come out and install the unit for the person, basically. So they don't have to worry about all the other stuff. We'll be able to look at the right permits, work out where it needs to go, help install the power supply. But in most situations, the Charge Qube is a temporary or semi-temporary. So you would plug it into the available power that's there. Say you've got a commando socket on the wall in your workshop or something, you just plug it into that. Say if you're having to pull in loads of extra power, and that's the key thing, is it's an appliance. So it's designed to just plug in like your EV would to some level. theoretically, you could probably plug it into an EV charger as well, if you've got one, if we made that work.
Well, I guess what I'm driving at is if I'm, say, a restaurant owner and I'm just realizing that EVs are a thing and that there's more and more of my customers who want this, right? And so I'm like, I should be smart about this and put some chargers at my restaurant. But then I do a little research and I'm like, I don't have that much power left over to do that. Is this kind of a perfect situation where, like you were saying, I can have the Qube put in and then, my restaurant's only open for a part of the day and that's when my charging is needed. And so maybe it makes it possible for me to put in even more chargers than I thought.
Yeah, no, definitely. I think it's great. It can just be designed to just drop in place in a car park, for instance, but whatever power is available and then just roll out the chargers. So we're doing them with CCS, but we're also doing them with things classed as level 1 in the US, which is obviously the slower AC charging, which in the UK is type 2. So the plan will be that we'll have these small little pavilions, which have 2 of those chargers on each, and you can basically just spread them out across car parking spaces, but then they all feed back into a central Qube, which is where you've got your battery pack in and your main power. And the idea is that in theory, you could drop them in and then you could just charge people per kilowatt, which is what most people do now. But it may also be a reason for people to come to your location. They know they can charge there. So you may be able to use it as an incentive to get people to come to the restaurant and say, actually, we've got free on-site charging for people that are eating at the restaurant. Maybe, I don't know, there's lots of pros and cons with it. There's also a lot of and like in the UK, with a lot of councils or states which are, they have mandates to roll out EV charging and they're going to struggle to hit their requirements. Well, potentially charge cubes could go into those locations. They could go in temporary whilst they put in permanent infrastructure, or you could drop it in and go, we think we want to put some chargers here, but we don't know what the utilization is going to be. No one's got that data. We'll put a charge cube in for 3 months with a load of chargers, see what the utilization is, and then you go, right, well, we need to put more chargers than we anticipated, or actually, we don't need to put chargers in that location. It was the wrong idea. That may be the other way of these locations saving money, to try and work out where should they be positioning these chargers long term for the right thing. And temporary events is the other big thing. You've got a week-long event and you've got no charging, or potentially drop a load of charge cubes in and you've got charging on site.
So there's a lot of flexibility in what you can accomplish for customers. Because, with the restaurant, depending on where that restaurant is, say it's between point A and point B, and it's one of those places that's, in the middle, you might want fast charging at that restaurant. And it's like, there's no way to accomplish fast charging at most restaurants with the power that they're going to have. But then with the multiple charging slots, that would be more for like an event or like a week-long, sort of thing where many people are going to be at a certain place for a long time, but it's only once in a while, kind of like a festival, like a music festival or something like that. What is the flexibility for customers in terms of having both like slow speed and high speed charging? Can you accommodate both?
Yeah, so the high speed charging we basically embed into the side of the Qube itself. So if you have a 10-foot Qube, basically we'd normally have a charge port either side, which would do the 240 kilowatt output, and then you could have the other pavilions coming off of the Qube as well separately. And that's what we're trying to look at the moment. So having both options. Having the pavilions that then do CCS rapid charge is quite hard because we like to do direct DC to DC. Which makes it obviously more difficult. I don't want to be running DC cable lines to these ACs. A lot better to run for that. But there's nothing stopping us to having, say, 63 amp or 32 amp 3-phase output from the Qube to a mobile CCS unit, because you can get those smaller 30, 40 kilowatt mobile CCS units. So potentially you could do multiples like pavilions of CCS units, but they would just be doing the DC AC conversions. There'd be a little bit of power loss, I suppose, but it would still be fairly efficient.
Can you do NACS, the North American charging standard?
Should be able to. The communication protocol is the same as CCS. It's just a different form factor. I don't see why NACS wouldn't be an option. Some of the companies we've been working with and talking to around the charge controllers, they already support NACS. So it's just finding the cables to do that. But in a lot of places, you could just people could just run an adapter if they really wanted to, obviously, to do NACS charging. Depends how it gets, how much does NACS get sort of taken on, I suppose, over the next couple of years. And is everyone going to go to NACS, or is there going to be this mix match? And if there's a mix match, it's which way do you go with the Qube? Do you focus on NACS and people have to have an adapter, or do you do the opposite way around?
I remember from Will's video that you guys don't need to trench. Is that true?
Correct. That's true.
Because, we talk about this all the time. Whenever a company wants to do something and they have to then go to getting the power company to install lines and trench and rip up the parking lot, that's what usually stops them, because they're like, you know what, guys?
We ain't doing this.
That's just going to be months of red tape. But you're talking about being able to basically just drop this off.
Yeah, so we're trying to treat it as a semi-permanent installation, which obviously brings with it different rules because it's not classed as a permanent installation. So there's certain legislation and certain rules around it that are different. So like a 10-foot sea container, 20-foot sea container, they're not seen as permanent installation, so you don't need planning for it. So you can just drop them in place. So as long as everything's classed as temporary, even if it's built to a manner where it could stay semi-permanently, the planning permission is very different and the way in which it's executed. There may be certain situations where you want to put a trench in if you're leaving it in for a long, long period of time. You don't want like cable tray or like, that sort of stuff along the floor. But in most situations, you can normally get away with having these basically like a cable tray with rubber feet that you just lie out and the cables sit into it. And then you put a cover over them so that it's neat and tidy. And that seems to do the job in most situations. And it depends where you position it as well. So if you're going to stick it right in the middle of a car park where loads of people are walking, you're probably not going to want to have cable tray. But in a lot of situations, you'll put it at the edge of a car park where actually you could run the cables on the other side of the sidewalk and then feed them in, rather than having to put it right in the middle of a car park or industrial premises potentially. You'll put it at the corner of the yard where actually people aren't heavily walking in that direction all the time.
Where did you come up with this idea?
I got really frustrated because no one was doing it. That was one thing that was really annoying. So about 5 years ago, we actually developed a smaller version of Charge Qube. It was like a pallet-sized unit, but we found that the components were so expensive because no one was doing high volt with inverters back then. It was all 48 volts. So by the time you did 48 volts and you had multiple batteries linked in series with multiple BMS systems, it just got to a point where it was so expensive, just no one was ever going to be interested in it. So we sort of parked it and went, we can't make this financially viable. We'll just leave it. And then over the last couple of years, I've started seeing more and more and more sort of second life batteries coming available on the market. And I've seen a couple of DIYers starting to put them in their houses and do like odd bits with them. But it sort of got to the point I was like, why is no company doing this yet? And then I've sort of realized you need a very specific skill set to be able to do it. In that we obviously Felton has focused heavily on automotive since it started. So we've been reverse engineering systems from the start, doing open source work from the start, like understanding how they work. And then my background was event world. So I did high power diesel generators for 6 years. So I did a lot of diesel generator stuff for Agreco. So I was sort of involved in that space. So we've got this odd mix where we've got engineers that know how to reverse engineer Tesla components and other systems, as well as experience with generators and temporary storage sort of systems. And then obviously we've got all the fabrication and manufacturing in-house as well. So we've just got a weird mix that allowed us to piece this together to become a product. But I think a lot of it came down to frustration in that I've been looking at the market heavily and going, well, there's all these people with fleets that should be driving electric, but all they do is make an excuse up so they don't have enough power at their premises, or it's going to cost us this much to put the power in and we don't own the premises. It's like, well, you need to remove that excuse somehow and cost effectively. So second life batteries in a container with charge infrastructure that say leased on a monthly cost, so it keeps it cost effective. They haven't got to pay large amounts of money up front. So you've just removed the complete excuse from the fleet operators as to why they can't go to electric. And you've removed a huge amount of the price barrier of having to do massive amount of infrastructure install on a premises you don't own.
There's two groups of people I think that really want to talk to you. One is like commercial developers, restaurant owners, all these customers of yours. Where should they go to find out more?
So we've got a website called chargeqube.com. That's Qube with a Q instead of a C. There's loads of information on there about the 3 different versions we're doing, which is the low power charging solution, the CCS, and then the energy storage product.
And then the other group, I think, are investors. We're here on Disruptive Investing, and I think that this is very disruptive. So if I'm interested, you just mentioned you're raising capital. Is this anything that a crowd-funded kind of investor could get in on, or is this you're going for like a seed round with a big institutional investor?
We're going for a seed A at the moment with sort of hopefully bigger institutional investors. We may potentially look at a crowd fund for a top-up. But right now we're trying to find some bigger investors that want to get on for the longer term, because obviously as we grow this, we're going to need to go international into lots of different locations and rapidly grow this and sort of fit this out in an international scale. So we need someone that can get involved now and actually grow with us as we push the product.
Now, there's one other possible group of people who might be interested in that would be homeowners. I know that it's a little oversized for most homeowner applications, but I feel like the idea of having a semi-modular power backup system is kind of intriguing.
You're just trying to get Chris to send you one.
Well, no, we don't have enough room around our house. But I guess, would it be possible for someone to say order one with, say, one Model 3 battery pack in it, and then have more of a house style inverter to power their house, and then that over time, in 4 or 5 years, they could buy another used Model 3 battery pack, which maybe now are even cheaper since Tesla keeps making more and more and more Teslas. It seems like if all I need to do is basically get a forklift, take it from the pallet from which it was delivered, I don't know how you get the batteries in there, but seems like, just get it in there, wire everything up, and then I've doubled the capacity of it, so I was already at, 60 or 70 kilowatt hours, and now I could be at 140. It just feels like, for a lot of people, that's pretty exciting. I know that people can do a DIY project where they buy a battery pack. I just know that a lot of other people don't feel comfortable doing that sort of high voltage work where it's like you touch the wrong wire and that's it. So is that something that you're thinking about? It seems like right now it's a small market, but do you think that it could happen?
So we've sort of avoided it from a liability point of view, I suppose. It's probably the main reason we've not looked. And there's a lot of competition in home energy storage.
That's true.
Considering a lot of people don't need a massive battery pack at home, and 20 kilowatt hours is normally enough for most houses.
True.
We've sort of stayed away from it, but I have been asked multiple times now. We've developed some clever hardware software to run these systems, which obviously makes the battery pack since they're still in the car, converts all the messaging over to communicate with different inverters. And that's something we've been working on for a while. And it's like, well, do we potentially release that? So if someone could take a battery, add that to it, talk to their inverter, because there's quite a lot of high voltage inverters now on the market you can buy and install. So I think the key thing for a lot of people is, if you're going to have solar input into your house, you must have to make sure you've got an inverter that can accept a high voltage battery pack. Don't go for an inverter that can do 48 volts. Go for an inverter that can do 400 volts plus, because the chances are in the future you can then add an automotive battery pack into the system rather than paying large amounts of money for a brand new battery pack that's no better. And you can pick up an automotive for a lot cheaper. There is quite a few good open source projects out there that I've come across which are starting to do this and reverse engineer bits of different batteries and make the communication protocol match what the inverters are looking for. And that seems to be the cost effective route to go. But I think the biggest thing for me is how do you justify it from a liability point of view, because that battery someone buys may not have been tested. But we have big test rigs here, what we can do discharge charge cycles of the batteries when they come out of the vehicles to make sure there is no issues with them before we put them into a Qube. And then when they go into a Qube, they're in a still box that has fire suppression systems in and monitoring and all that sort of stuff. So if anything did ever go wrong, we know about it pretty quick. And we can take batteries offline quite quickly, and potentially the fire brigade can approach it in a certain manner and execute in a certain way. So that's the extra stuff we've got in there just to make sure it is safe long term.
Last point here, I think, would be, could you use the Charge Qube more like a Powerwall or a Megapack, in the sense of kind of it being a bit more grid tied? Obviously, the use case that you're trying to go for is where you don't have a strong grid connection to kind of trickle charge up this battery and then dump it into somebody's car. But if there was a medium connection for, say, a larger commercial building, could they be using this to kind of, let's say they had a ton of solar on their roof or something like that, if it was a warehouse, could they kind of use it in the same way that some people use Powerwalls, where they're able to sell the energy when it's the price is high, and either buy energy when it's low, or just use solar energy?
Yeah, I don't see why not. So the current system we've developed, we're doing it as an appliance, so it's not feeding back to grid, basically, mainly because you can drop it in, install it, and the DNOs, the energy suppliers, don't care. They don't need to know about it because they see it's just a car. So it's like drop it in, plug it in, doesn't feed back, makes it super fast to install. But alongside that, yes, we've been looking at how can we potentially do buying and selling of electricity. So buying it at night when it's cheap, selling it back when it's in the daytime, or say you've got a premises, you don't have enough power in the day. You're running a machine shop and actually you want to put some new machines in, but you haven't got enough power. But at night when you shut down, you've got more than enough. So that's the other potential, is you basically fill the Charge Cube up at night, bring your machines online in the day, and it just feeds back into buffer your available power. It also does your phase balancing to make sure your phase stay in balance. So there's a huge potential around that long term. It's just trying to get through the legislation side of things, that how would you approach the electric companies to go, oh yeah, we put a 450 kilowatt hour battery onto the grid connection. But don't worry, it won't feed back. That's the bit to get through. Which in the UK, it's a G99 application. So you basically do an application. It takes only about 3 months or so to go through, providing the product is certified. And then they basically tell you how much can you feed back and how much can't you. But at that point, you can bring the battery online then, but you're limited to how much power you're allowed to put back onto the grid, how much you're allowed to counteract your usage, basically. Most times you'll just go, I want to make sure you're not going to export, but you're going to get your usage to zero. That's what you're going to aim for. But in some situations with the bigger stuff, like the mega pack stuff, they want to be selling that power back out when it's needed and making a premium on it. We could do that. I don't know at what point we would do it. The algorithms, the software is a little bit more in depth, and it's trying to get that certification and pick the right locations where they'd allow you to do that. Because in the UK, most places will only allow you to do, I think it's 11 kilowatts feeding back. It tends to be the natural cap, which obviously isn't that much in the grand scheme of things. So you'll see a lot of these big mega packs are positioned in very specific locations where they have a tie to a large power source where they can buy and sell it back at high rates.
Seems like the limiting factor is the number of EVs and number of EV batteries that you can harvest. Is that what you guys think of as the limiting factor for your company? Have you projected out? I mean, obviously there's more and more EVs now. So is that going to be not a problem because there's just so many of them aging and getting in crashes?
Yeah, I think there's so many of them aging now that I don't think we're going to run into problems. I think the other thing that we've started looking at recently is second life batteries from China. I know that sounds really weird, but obviously China have a huge amount of EVs and you can't recycle stuff in China. So you're not allowed to build custom vehicles. You're not allowed to use components in stuff. So you end up with a lot of second life potential coming out of China long term, providing there's ways of buying it from China out, then it could be a huge market there. But I think just understanding the recycling market at the moment and the fact that the recycling companies are still struggling to sort of grow enough, build big enough machinery to recycle the batteries. I think there's this weird chicken and egg with the recycling companies as well, because they're going, oh, there's going to be all these EV batteries. They're like, well, do we build the machinery now or do we wait for the demand to be there? And suddenly we're starting to see these batteries are lasting so much longer that any recycling company that has upscaled has gone, well, there's not enough batteries for me to actually use because they are getting reused, they are getting repurposed. But one big thing we think we may struggle with is some of these companies starting to go sell to chassis. That could be the problem. Is a lot of companies are going to sell to pack, works fine. But there is talk with some of the companies, are they going to be able to put these cells directly into the chassis of the car and like embed them as a structural element, which they do to some level, but they won't be in their own case. They might be the bottom of the battery, but the top part of the battery is actually part of the structure of the car. So when that starts to happen, it's like, well, how do you then use those in things like Charge Qube? Do you end up bringing a car in and cutting off key parts of it? So you end up, this is probably what's going to end up happening, but at the same time that becomes a massive problem for recycling as well, because how are you going to recycle these? So it could be an interesting stage in the future. I think we're still a little bit of time away from that yet, and I'm sort of hoping that the governments of the world will turn around and go, no, car manufacturers, you are not allowed to sell direct to chassis because it's going to make recycling very difficult. Which is what happened sort of within Europe, where they said actually the battery packs need to stay modular so they can be repaired. So you can swap a module out. That seems to be disappearing now. More and more of them are going to bigger and bigger modules. So they sit within that legislation of it must be a module, but you didn't say the module couldn't just be one big module. So they're finding ways around that. But I'm hoping that cell to chassis doesn't become a thing, because obviously it will make recycling way more difficult.
Here's a far out question, but if Elon's right and Optimus is going to be, this humanoid robot is going to be made in the billions, I mean, could you be using, say, 5 kilowatt hour Optimus batteries in the future in your Charge Qube?
Don't see why not. They
could even walk them to it and drop it off.
Yeah, they could. The question is, you can have cars in the future. You're just going to get piggyback from an Optimus 17.
Oh, this has been really.
Are you even going to leave the house? You're just going to send your robot to do stuff for you, and no one's going to leave the house. You just go with Optimus spots with different people's faces on them.
It's true.
Well, Chris, thank you so much. This was really interesting. I'm so keen to see how well your Charge Qube business goes. It sounds like, you're taking what would have been garbage recycling,
Yep.
and you're turning it, you're reusing it in a pretty innovative way.
Yeah, really smart way.
Yeah, so it's that whole circular economy thing that everyone keeps talking about but not actually doing.
Mm.
I'm trying to, actually do it, I think
Yeah.
is the key thing now.
Well, thank you so much for joining us today. And if anyone's interested, I guess they head over to chargeqube.com. Charge the Qube is with a Q, QUBE.com.
Thank you, Chris.
Thank you very much. Cheers.